Approximating rational numbers. Identify square root of 5 as rational or irrational and approximate it to the 10th place. Well, if this were rational, that would mean that we could think of an integer or whole number that we can multiply by itself to equal 5. So, for example, 6 times 6 is 36. So square root of 36 is rational. But the square root of 5 is irrational because 5 is not a perfect square like 36. So it's an irrational number, and now we're going to approximate it to the 10th place. So let's start by looking at what two perfect squares 5 falls between. We've got 1 times 1 is 1, 2 times 2, 3 times 3, right? I can keep going. 4 times 4, 5 times 5, right? You get the idea. But if I'm looking for the two perfect squares that 5 falls between, it would be square root of 5 would be between square root of 4 and square root of 9. Is it closer to square root of 4 or square root of 9? Well, if I'm looking to see which one it's closer to, it's actually much closer to the square root of 4, right? Because it's only 1 away. The number inside the radical is only 1 away. Here, it's quite a bit more away. So if I had to approximate this, and actually let's look at, let me get rid of this. Let's look at what these square root values are. So the square root of 4 is 2. Hold on, let me get my pen. The square root of 4 is 2, and the square root of 9 is 3. So the square root of 5 is between 2 and 3, but like we said, 5 is much closer to 4, so it's closer to 2. So I would probably start with trying 2.1 or 2.2. And when I say try, that means we're going to multiply 2.1 times 2.1, the old-fashioned way, right? Multiplying by hand. So I get that, and then I get 2 and a 4, and I add, and then I have 1 decimal place, so I need 2 decimal places in my answer. So this comes out to 4.41. Let's try 2.2. So 2 times 2 is 4. 4. Got a lot of 4s here. 4. And I add it and I get 484. Right? And a decimal place here, a decimal place here. So 2 decimal places in my answer. I still haven't gotten to 5 yet though. So let's try 1 bigger, right? 1/10 bigger. So now I'm going to try 2.3. So 2.3 times 2.3 is 9. That's 6. That gives me 6, and that's 4. So 9, 2, carry the 1. And again, decimal place, so I need 2. So the square root of 5 is in between this number and this number, but which one is closer? Well, 5 minus 4.84 is 0.16 away, right? So 4.84 is 16 hundredths away from 5. And our other number is 29 hundredths away from 5. So the closer one is 4.84. So the best approximation to the 10th place is 2.2. Because when we tried 2.3, it was too big, right? 2.2 times 2.2 is closer to 5. All right, this one is similar. So here we have the area of a square field is 50 square feet. Approximate the length of one side of the field to the hundredths place. So again, we're doing the same kind of thing. We're approximating a square root, right? Because if the area is 50, and you know that the side times the side is how you get the area, then we're looking for the square root of 50. So first step, just like the last one, what two perfect squares does 50 fall between? Well, there's 49, which is 7 times 7. And then there's 64, which is 8 times 8. Right? Square root of 49, square root of 64. This is 7, this is 8. 50 falls in between these two, but it is much closer to 49. So just like we did for the last one, we're going to start with 7. Well, actually, let's go a little bigger. Let's start with 7.2. So 7.2 times 7.2. And then 14, and then 50. So let me add real quick. And then decimal place, so 2 decimal places. So this gave us 51.84. So it's too big, right? So let's try 7.1. And I say it's too big because, remember, we're trying to get 50, right? So 1, and then 7, and then 7, and then, wait, 1, and 7, and then 7, and then 49. I had to make sure I was doing the addition right. Ooh, that's much closer, right? Much closer, but it's still too big. So how would we go smaller, but not 7, right? Because 7 times 7 is 49. So what if I try 7.05 times 7.05. Now these multiplication problems are going to get longer, unfortunately. 0, 0, 0, and then 5, and then carry the 3, right? 5, yeah, carry the 3, and then 49, 5, 2, 0, carry the 1. Ooh, that's pretty close, right? So you would keep, I mean, most of the time when you get a question like this, it's going to be a multiple choice question. So in this case, you would now look, you know that it's less than 7.1, and you know that it's more than 7.05. So I'm not going to spend your time here doing multiplication for 7.06 and 7.07, 7.08, and 7.09, right? You can do that, but if it's a multiple choice question, then you can look and see what the choices are and pick the one that makes the most sense based on what we've learned here, which is that it has to be less than 7.1, but more than 7.05. All right? And the reason why I knew to go to 7.05 is because 7.1 is like 7.10, right? So then I thought, okay, we want to get smaller. It would be 7.05. All right, that was a workout, right? So time for an easy one. So this one, when you're asked to find the square root, when you see that square root symbol, it means what positive number times itself equals the number inside. So we know that the square root of 25 is 5, right? But then there's a negative out front, right? So this negative out front makes our answer negative. Okay, so for this one, we have some number to the third power equals 27 over 64. So x to the third means that we're doing x times x times x, right? So that means that we're doing some fraction times itself that equals 27 over 64. So you have to kind of think about, you can't solve this using subtraction or division or even multiplication. You just have to try to think about what number times itself equals 27. So start with the small numbers. We know that 1 times 1 times 1 is 1. That's the easiest, right? 2 times 2 times 2 is 8. 3 times 3 times 3, well, 3 times 3 is 9, and then times 3, 27. All right, how about 4 times 4 times 4? Well, 4 times 4 is 16, times 4, 64. I think we found our numbers. So we know that the numerator is 3 because 3 to the third power is 27. And the denominator is 4 because 4 to the third power is 64. So x would equal 3/4. Now, you may also have an option of x being negative. Why can't x be negative here? Well, if we do a negative times a negative, we get a positive. And then if the third one is also negative, now we've got a positive times a negative, which would give us a negative answer. But this is positive. So in order for the answer to be positive, these all have to be positive. All right, last one. So we're solving this equation, and I'm going to write this out. X squared means x times x equals 169. So what number times itself equals 169? Well, go through the perfect squares in your head. We went through a bunch of them earlier. We can go all the way up to 12 times 12 is 144. So that's not quite big enough. The next one is 13 times 13. That ends in a 9, so that's looking promising. That's it. So that means that x could be 13, right? Because 13 times 13 equals 169. But there's another answer that will also work here, because negative 13 times negative 13 is also 169. So the answer here for x would be plus or minus 13.